All right, so if you guys could go to the slide where it says average velocity, no big surprises here. If we're going to find the average velocity from some object or some organism, like let's say this rabbit moving through the prairie, we simply say that the average velocity, right, is equal to the displacement vector divided by how much time has gone by. Okay? And another way of saying that is simply change in r, right? That's displacement vector over time. Okay? So this slide here that says average velocity is saying, so what would be the average velocity of the rabbit in the last problem? Well, what was our displacement? Our displacement was just, if my memory serves me correctly, 6.96 I, right, minus 12.92 J. Okay? And the time interval, well, let me think really hard. It was between 7 and 5 seconds, right? So that would just be 7 minus 5, which would be 2, right? And so if I just take 6.92 divided by 2, so you would have to divide each of these guys. So this is going to be 2. So I'll just rewrite here. 6.96 I minus 12.92 J divided by 2, right? I want to divide this guy by 2 and this guy by 2. And so my velocity vector, my average velocity vector, is simply going to be, I'm getting 3.48 I minus 6.46 J, okay, which is just both of these divided by 2. And now I have a velocity vector. Okay? Right? Does that make sense? Okay, so if you guys could advance to the next slide. Pause if you need to think about it for a second. That's fine. That's why these asynchronous videos are kind of cool. We want to apply this to the situation of an instantaneous velocity. And remember, we talked about this before. The only difference between the average and instantaneous velocity is, well, two things. You're finding the velocity at one given point. So if, like, let's say this is my curve over here, right? Instead of finding the average velocity between like these 2 points, I'm finding the instantaneous velocity right there, right? But remember, we said that that's just the derivative, right? So that's going to be v equals dr, right? The change in displacement with respect to time. Okay? So that's the same thing as saying that v is really dx dt I plus dy dt j plus dz dt k, right? So all you're doing is you're taking the derivative of each component with respect to time. And so in the case of the rabbit, what would that look like? Well, the rabbit, if I remember correctly, the x component was always negative 0.31 t squared plus 7.2 t plus 28, right? And the y component was 0.22 t squared minus 9.1 t plus 30. Correct? Cool, right? So if I want to find the instantaneous velocity vector, right? In other words, the velocity at a single point in time, I would just say that I need to put in my dv dt, right? So this guy, I want to take the derivative of the x component, right? Which is, in this case, 2 times negative 0.31, which would be negative 0.62 t plus 7.2 t, sorry, just 7.2, and that's all I, right? So I just took the derivative of this. I took dx dt of this guy, and I put that right there. Okay? Now I want to do the same thing over here. I want to take dy dt and put it here for the j component of my velocity, my instantaneous velocity. So that's going to be 2 times 0.22. That's 0.44 minus derivative of 9.1t is just 9.1. So, sorry, that's going to be 0.44t minus 9.1 j. Okay? All right. That is my instantaneous velocity. So that what this means is I can take any time in the entire world, put it inside these t's, and I have my velocity vector for that point. In other words, I have the magnitude of the velocity and which direction I'm actually moving in. Okay? So let's follow that out for this problem here. Says what would be the instantaneous velocity at specifically 3 seconds. So we want t equals 3, right? Well, if we put in 3 here and 3 here, we get a value of, I get 5.34 I minus 7.78 j. As always, feel free to check me, okay? But this means at this point in time, right, this t equals 3 seconds, that's the velocity vector, right? That is, from this, we can find out how fast you're actually moving, the speed, the magnitude of velocity, right? Simply by using Pythagorean theorem, this squared plus this squared square root, right? And we can also find the direction that you're moving by taking inverse tan of this over that, okay? So there's a little bit there, okay? Feel free to stop the video at this point and kind of like go through the process. But really all we're saying here is that your average velocity is your displacement vector divided by time. But if you want instantaneous velocity, then you actually have to take the derivatives with respect to time, substitute in the time, and then actually get your velocity vector at each point, okay? So this is at one specific time in time, right? This is at one specific time. This is at an interval, in this case, 2 seconds, all right? So after this video, we're going to begin projectile motion, which I think is actually quite a bit of fun. It's a lot like the laundry list stuff, except now there's 2 laundry lists for every problem. So I'll see you there.